This course is divided into 3 sections: design, deployment, and defense. However, due to particular current events, I am actually going to be releasing these videos in reverse order. That way, people don't have to wait for the information that is most important to them. Releasing the videos in this order also means that the course will generally get more difficult as it goes on, allowing people to ease themselves into it. Now for an overview of what we'll learn. Defense. This section will cover the things that countries and individuals can do to defend themselves from a nuclear attack and handle the aftermath should the worst come to pass. Some of you watching this may already think that that sounds a little bit crazy, especially if you are American. Our decades-old doctrine of mutually assured destruction very fatalistically assumes that any kind of nuclear blast, let alone war, would be totally unsurvivable, especially because it would trigger a full-scale retaliation which would presumably make the entire world unlivable. Pop culture has gone a very long way in perpetuating this belief. There are 2 flaws with this plan. The first is that Russian nuclear doctrine includes plans for a nuclear war that is limited in scope. It is quite possible that a Russian first strike against American or European targets would involve a small number of warheads launched against relatively unimportant, unpopulated areas, just to gauge our response. The Russian government would then respond in kind, following something that more resembles tit-for-tat escalation than mutually assured destruction. We live in a world where the leaders of a country in control of thousands of nuclear warheads believe that it is possible to use them in a limited capacity. And unfortunately, that means the rest of us have to prepare for the eventuality that they try to. The second problem to consider is that a full-scale nuclear war wouldn't necessarily make the entire world uninhabitable. At least, not anymore. 2 important factors to consider are the disarmament efforts and population growth that have occurred in recent decades. The United States and Soviet Union used to have over 30,000 nuclear warheads each, but thanks to disarmament, the US now has less than 4,000, and Russia probably has less than 6,000, as per the Wikipedia pages on their arsenals. This has happened while America's population, and sprawling suburbs, have gotten bigger. To gain perspective on what bombing campaigns look like in general, we're going to examine the First Gulf War. During that war, coalition aircraft used over 200,000 individual bombs on targets across Iraq and Kuwait. That's according to the Gulf War Air Power Survey, link in the description. Their combined effects largely incapacitated the Iraqi military. Russia and the United States are both several times larger in both population and area, however, and have much more well-equipped militaries. If a full-scale war were to break out, each side could easily have to use over 1 million separate, non-nuclear bombs in order to achieve a similar effect. And that's just to neutralize those assets that are used directly by the military, such as combat aircraft hangars, as well as some that have large but indirect military importance, such as a combat aircraft factory. But this begs the question, why do you need so many bombs? The reason is that blast radius only increases with the cube root of bomb yield. That is to say, doubling the blast radius requires increasing the size of the bomb by a factor of 8. A nuclear bomb with a yield of 1 kiloton only has 10 times the reach of a 1-ton conventional bomb. Likewise, a 1 megaton bomb only has 10 times the reach of a 1 kiloton bomb. This can be calculated as a consequence of the ideal gas law, and I will explain why during the design section of this class. I made 4 graphs, 2 in metric, 2 in imperial, to show you what the relationship looks like. The graphs on the left show how far from ground zero you would have to be in order to be safe from the blast if you were inside and away from the doors and windows. The graphs on the right show how far you would have to be in order to be safe if you were in a tornado shelter. It's possible to survive if you're closer, but serious injury becomes much more likely, as does death, of course. And obviously, better shelter always improves your odds. I made those graphs using data from a website called NukeMap, which will be a regular resource in this class. Link in the description. It's run by Alex Wellerstein, a historian working for the Stevens Institute of Technology. Now granted, so far I have been focusing on the blast, but nuclear bombs also produce heat, radiation, and fallout. I will talk about all of these topics in this course, but the blast is usually the biggest issue and the primary intended effect. This is especially true when the bombs are being used to demolish buildings or neutralize materiel assets. The sprawling nature of both cities and military bases limits the damage that can be done with a single warhead, even if it is an extremely powerful one. Many of the largest military bases in the United States are located far from urban centers, and due to real estate prices, among other considerations, many of our most important factories are too. These include the TiMet titanium mill in Henderson, Nevada, the Hemlock Semiconductor Corporation plant in Hemlock, Michigan, the Rank America facility in Muskegon, Michigan, which makes engines and transmissions for combat vehicles, and the Materion Brush beryllium plant in Elmore, Ohio. Even if we assume that every nuclear warhead deploys successfully and destroys as many strategically important targets as hundreds of non-nuclear bombs, it is by no means certain that the US and Russia could paralyze each other's militaries using only the weapons currently in their arsenals. Deployment. This section will discuss the transportation of nuclear weapons, the circumstances for their potential use, and their intended, as well as incidental, effects. That will include descriptions of the different vehicles used to deliver the weapons to their targets, and their differing advantages, disadvantages, and countermeasures. It will discuss the differing effects of the different types of nuclear weapons, and finally, we will discuss the most likely scenarios for their use. Design. This section will explain how a nuclear bomb works at the nuclear level. We will discuss how different modifications to bomb design can create differing effects, and explore current and future research into nuclear warheads, including the potential for a clean nuclear bomb, or as I call it, a boron bomb, for reasons that will become clear later. If any of that interests you, please subscribe to my channel, and thank you for watching.